Hello and welcome back all the students. So we are back here again with one more new video. So in this period we are going to talk about the chemical properties of the ethers. So we had completed with the alcohol part, preparation and their properties, both physical and chemical. Then with the phenol part also we had completed. We had also completed with the preparation of ethers. Now we'll go for the chemical properties of ethers. This is also a very important point. Now in the earlier lecture only I have told you that what all methods are there for the chemical properties of ethers. I will shortly describe those methods one by one. Number one, laboratory method. Then second we have reactions involving alkyl group ethers, right? Then the third method is reactions involving carbon oxygen bond, and the last reaction is electrophilic substitution in aromatic ethers, right? So you all know what is the aromatic ethers. Aromatic ethers are nothing but the particularly ethers which are attached to the benzene ring are called as the aromatic ethers, right? So this is what is the chart of the chemical properties of the ether. Right, so what are those methods? Laboratory method, reaction involving alkyl group of ethers, reaction involving CO bond, and electrophilic substitution in the aromatic ether. Okay, now under this methods we also have a sub methods. In the reaction involving alkyl group of ethers, we have a first reaction, that is the formation of peroxide. Under this method we have three methods, that is the reaction with dilute H2SO4, and then second we have reaction with PCl5, and third reaction we have is reaction with concentrated HI and HBr, right? So this all methods are there under this particular reactions involving carbon and oxygen bond. And under the electrophilic substitution reaction we have the first method, that is a very common method, halogenation of ethers. Second method, Friedel-Crafts reaction, and the third method is nitration reaction, right? So this all methods we are going to learn in today's period. See, you can see it in this way. All the methods, that is the reaction with dilute H2SO4, reaction with PCl5, reaction with concentrated HI, HBr, halogenation, Friedel-Crafts reaction, and nitration reaction, right? So I hope again the chart is very much clear to all of you, right? So now let's go for the reaction. Okay, now the first reaction here in this case is laboratory test for ethers. Now how to identify the ethers in the lab? So there is a special test here. What happens? Ethers are a neutral compound in the aqueous medium. You have to remember this. Ethers are neutral compound in aqueous medium, right? Then ethers do not react with the bases, cold dilute acids, reducing agent, oxidizing agent, and active metals. However, ether dissolve in a cold concentrated H2SO4, and which leads to the formation of a oxenium salt. So we are going to see that reaction only. See, this is ROR dash. So that day I told you what is the meaning of R dash. See, here it might be a CH3 group, and here it might be some other alkyl group, let's say C2H5 group, right? So whenever R dash is there, that means the alkyl groups are not same. On the other side the alkyl group will be different, right? So here when we treat it with the H2SO4, now how is this H2SO4? This H2SO4 is a cold concentrated acid. When it reacts together, then it leads to the formation of a complex. See, this complex is like this, right? This particular complex is nothing but called as the oxenium salt of ether. Oxenium salt of ether, right? So due to this formation, we can say that the ether is formed in the particular reaction. See, this ROR, this group itself tells you that the particular ether is present in the given compound, right? So this is the detection test for the ethers. Okay, now let's go for the second reaction. Reaction number second, that is the reactions involving alkyl group ethers. Reactions involving alkyl group ethers. Reactions involving alkyl group ethers. In this we have the first reaction, that is the formation of peroxide. Formation of peroxide, right? See, ethers combine with the atmospheric oxygen to form a peroxide. What happens here in this reaction? Ethers will combine with the atmospheric oxygen to form the peroxide, right? So this is the reaction I am showing you. CH3, CH2, O, C2H5. It reacts with the oxygen. See, long constant, or we can say long contact interaction with air, right? So when you keep a long contact or interaction with the air, you can see that it will get converted into a peroxide. So how is this peroxide? CH3, CH, O, OH and O, C2H5. So this particular thing is nothing but called as the peroxide of diethyl ether. Peroxide of diethyl ether. Diethyl ether. See, the obtained peroxides are very, very hazardous in nature and they decompose violently at a higher temperatures, right? Okay, now let's go for the next reaction, that is the reactions involving carbon-oxygen bond. So you can note it down, the third reactions. Reaction involving carbon and oxygen bond. See, try to understand. I am not telling you breaking carbon and oxygen bond. I am only saying carbon and oxygen bond reactions, right? So breaking cleavage is a different thing, and only reactions involving carbon and oxygen bond is different thing, right? So here we are not breaking any carbon and oxygen bond, but only we are seeing the reactions where the carbon and oxygen bond is involved, right? So here in this case, the first reaction is with the hot dilute H2SO4 hydrolysis, right? So the first reaction is reaction with hot dilute sulfuric acid hydrolysis, right? So in this reaction, ethers when heated with the dilute H2SO4 undergoes hydrolysis to give the alcohols and phenols, right? So here see ROR plus H2O, or I can split it and write it HOH in presence of a H2O delta 2ROH, 2 moles of a alcohol is obtained. Then see ROR dash. So you all know that R dash is different alkyl group and R is different alkyl group. Here both the alkyl groups are same, but here as I have put the R dash, that means the alkyl group is different, right? So treated again with the water in the acidic medium, heated, it gives you 2 alcohols, ROH and ROH. Then AROR. See, now instead of using the R, I have used the aromatic group now. and we treat it with HOH, that is the H2O, H plus acidic medium, it will give you a AROH. See, the phenol is obtained in this case as well as the alcohol is also obtained in the reaction, right? So I hope that you have understood the reaction. Okay, now under this we have the second reaction, reaction with PCl5. Reaction with PCl5, that is phosphorus pentachloride. So what happens? Ether reacts with the PCl5 to give the alkyl chlorides. See, ethers react with PCl5 to give the alkyl chlorides, right? So I will show you the reaction ROR dash. So again, you know what is the meaning of R dash. On both the sides the alkyl groups are not same, plus PCl5 heated, it will give you RCl plus R dash Cl plus POCl3, phosphorus chloride, right? So here you can again understand this is a different alkyl halide, this is a different alkyl halide. So both the alkyl halides are different in a nature, right? So let's say this may be a CH3Cl and this may be a C2H5Cl, right? So ethyl chloride and this is the methyl chloride, right? So I hope that you have understood the particular reaction, right? Okay, now let's go for the third reaction. So what is the third reaction? Reaction with hot concentrated acid like HI and HBr. You all know that HI and HBr is also a acid, that is the hydrogen iodide and the hydrogen bromide. So what is the reaction? Reaction is very simple. So ROR plus HX. X means can be any alkyl halide or any halogen group. It may be a HI or it may be a HBr also. So any halogen group you can attach. So when they are heated, it gets converted into RX plus ROH, right? So this is the reaction. Okay, now we can also use the alcohol for the reaction. When you treat this alcohol with the HX, it will directly get converted into alkyl halide plus H2O. So both the reactions are possible. The reaction of a ether with the HX and the reaction of a alcohol with the HX. The product obtained will be same. That will be RX and RX. RX is nothing but the alkyl halide, right? So I hope that you have understood this particular reaction. Okay, now let's talk about the next reaction. That is the fourth reaction. In this we have a electrophilic substitution reaction in aromatic ethers, right? So this is the reaction we are going to see. So what happens here? The alkoxy group in the aromatic ether is a ring activating group. It is also called as the ortho and para directing group. This can be proved with the help of a resonance. I told you that why do they undergo the electrophilic substitution reaction? Because they are forming the ring activation, and the ring activation is taking place at the ortho and para position. That can be proved with the help of a resonance. So I have shown you the resonance that day. You might be remembering it. Okay, then under this we have the first reaction, that is the halogenation, right? So in the halogenation what happens? We are going to take a anisole for the reaction. Anisole undergoes the bromination with a bromine in acetic acid solution. In absence of a ferric bromide as a catalyst, it is due to a activation of a benzene ring by the methoxy group, right? So here you can see the reaction. OCH3, this is called as the anisole. What is the other name of anisole? Methoxy benzene is also called as the anisole. Then when it is treated with the combination of a Br2 and CH3COOH, that means bromine in acetic acid solution, it will get converted into a two products, that is OCH3 and Br. That this is the para substituted product, or you can say para bromoanisole. This is 90% a major product, plus OCH3 and Br, this is 10%, and it is orthobromoanisole. Orthobromoanisole, right? So para substituted and ortho substituted products are obtained in the reaction. This is the halogenation reaction. Okay, now the next reaction under this is Friedel-Crafts reaction. Friedel-Crafts reaction. Right? So generally this Friedel-Crafts reaction, we use the anhydrous AlCl3, right? That is the Lewis acid as a catalyst for the reaction. Last year you all have learned this reaction in the 11th standard, Friedel-Crafts reaction. And what we are using as the catalyst, AlCl3, that is the aluminum trichloride, is used as the catalyst, that is the Lewis acid. Remember this, right? So this is a very very famous reaction and it can be asked in the exam. Okay, now what happens here? Here also we are going to take the product, or we can say the reactant, as the anisole, and this anisole reacts with the alkyl halide and acyl chloride in presence of a anhydrous AlCl3 as a catalyst. It will get converted into 4-methoxytoluene and 2-methoxytoluene. Right, so let's see the reaction quickly. See, this is a anisole, that is the methoxybenzene. Anisole reacts with the methyl chloride in presence of catalyst AlCl3, that is anhydrous AlCl3. It will get converted into two products, that is the 4-methoxytoluene plus 2-methoxytoluene. Right? So my dear students, I hope that you have understood this particular reaction, right? It is a very simple reaction. The reaction is carried out in presence of a Lewis acid like AlCl3. This is very very important, right? So the reaction condition is important, right? And we are using the anisole. Now what is this toluene? Whenever to a benzene ring CH3 group is present, that is said to be a toluene. See, this group is called as the toluene group. CH3. This group is called as the toluene group. Whenever to a benzene ring methyl group is present, it is said to be a toluene. And the other name of a toluene is methyl benzene. This is what you need to remember, right? The other names I told you. You should remember the other names of the compound, because in the exam they may not ask you only toluene. They may directly ask you carry out the reaction of a methyl benzene. So it should immediately strike that methyl benzene is nothing but the toluene, right? Okay, but here the first reaction we carried out with the help of a methyl chloride. Now we can also carry out this reaction by using the acetyl chloride. Now what is acetyl chloride? Let's carry out the reaction. See, this is OCH3 anisole. Again we are going to carry out the same reaction, that is the Friedel-Crafts reaction, but here we are going to use the CH3COCl. See, this is nothing but the acetyl chloride. What is this? Acetyl chloride in presence of a same catalyst, that is AlCl3, which is anhydrous AlCl3. Now what will be the product obtained? Now instead of toluene, the product obtained will be COCH3. See, this group COCH3 group will get attached to this benzene ring. So now it becomes 4-methoxy acetophenone. 4-methoxy acetophenone, and a mixture is also obtained. This is called as the 2-methoxy acetophenone. methoxyacetophenone. Right? So I hope that you have understood that when we change the particular reactant, you will get the different product. Now what is acetophenone? See, whenever to a benzene ring COCH3 group is attached, it is said to be a acetophenone. Right? Whenever to a benzene ring COCH3 group is attached, it is said to be a acetophenone. Right? But here we also have at a fourth position methoxy group, so it becomes 4-methoxyacetophenone, and this becomes the 2-methoxyacetophenone. Now let's go for the last reaction, that is the nitration reaction. Now what happens in this reaction? See, in this reaction, anisole, we are going to again take the reactant as the anisole. Anisole reacts with the concentrated nitric acid in presence of a concentrated sulfuric acid to give a mixture of orthonitroanisole and para-nitroanisole. Again, the mixture of product is obtained. So let's look at the reaction. So again, we have taken the anisole OCH3, that is the methoxybenzene, anisole, in presence of a nitric acid concentrated HNO3, and also the reaction takes place in presence of concentrated sulfuric acid. It gives you a product of mixture of product, that is OCH3 and NO2, plus at a second position we have the OCH3 and NO2. So what will be the name? It is very simple, 4-nitroanisole and 2-nitroanisole. Right? It will be a major and it will be a minor product. Right? So I hope that you have understood this particular chemical properties. I hope that I have covered all the chemical properties which are there in the particular ethers. Right? Okay, now what is remaining? The only point which is remaining is structure of alcohols, phenols and ethers. Right? From this chapter we are only remaining with the structure of alcohols, phenols and ethers and the uses of alcohols, phenols and ethers, and with this we will finish with this particular chapter. Right? So in the next video we will be talking about the structure, alcohols, phenols and ethers, which is a very important topic. Right? So it is enough for today. Thank you very much.